Hey guys, just finished my first replicate for TKS. Basically, built a disease diagnosis project, and you would basically put MRI scans, and it would let you know whether a person has Parkinson's disease or not, just based on those images. And the way it does this is by using computer vision through Google's Colab, and I use YOLO V8 by Ultralytics, which is the object detection model. And basically it detects certain patterns between images, and using those patterns is able to identify and correctly recognize whether an image represents Parkinson's patient or not. So here's my demonstration project. So first of all, since we're in Google Colab, we're going to need to connect to our GPU. So just press connect over here. I'll take a second, but it should be connected. Make sure you're connected to the GPU, not the CPU. So when you go here, select T4 GPU instead of CPU and TPU. Basically, it'll just give you faster performance and you'll get your work done quicker. Okay, so now we just want to make sure our GPU is properly connected to the system. And then we create a variable called home for easier management of data paths. Then we actually install YOLO V8, which I mentioned earlier would be our object detection model. There are two ways to install it. First is by using pip, and the second way is to use the GitHub cloning method, but we'll just be sticking with pip because that's just simpler. So now we work with the command line interface. So we just tell the goal of the model, and here we use model equal predict to have the YOLO V8 inference run on multiple sources, and it that code also allows it to automatically download the latest YOLO V8 release, and it tells it that we're going to be using the prediction model. So we'll just run that, and now we're going to be setting up our Python environment. So just run all these code blocks. We can queue them one after another, and they'll run by themselves in queue. And here comes one of the most important parts, is actually putting in our data set for the model to process. So for my data set, the one I used, I have my own API key. So unfortunately I can't show it to you, but I basically annotated my own images for the Parkinson's detection algorithm. And these images I found using PPMI, which is a Parkinson's disease detection database provided by the University of Southern California. And I had to apply to that, and thankfully they gave me access to that database so I could complete this project. So I'll just be copy pasting my API key. And you can use Kaggle, GitHub, anywhere you want to get your data set. I just use my own stuff, so I'll just blur that out since I don't want anyone else seeing this as it's private info. But here. Okay, so once that's done, we just run the code. And then we proceed to custom training our model. So typically for smaller models, you could maybe recommend 100 epochs, which basically means how many times it runs over them and how many times it gets to train. I do 100 for this model just because we have enough time, and it shouldn't take more than 15 minutes since we only have about 102 images. So let's run this model, and I'll get back to you in a bit since it's going to take a while. Alright guys, so our code is finished running and the training appears to be done, so let's go check our results. So this will just enable us to see our results easily. Here, if we run this code, look at the chart, and it says it has over 100, it has about 100% confidence in its predictions. So here it will display charts of some metrics or and accuracy over time and stuff like that. Here, it will give us another demonstration of its accuracy and predictions with its models. And finally, we can use this to validate our custom model. So just run this and it will give us the results. Shouldn't take too long, hopefully. Alright, yeah, so we got 98% accuracy overall, 96% accuracy in detecting whether a image was of a control group basically a person without Parkinson's, or the MRI scan was of a person with Parkinson's, which had 99.5% accuracy, which results in an overall accuracy of about 98%. Wow, that's really great predictions over there. And here's also another inference, which basically allows us to save our results with this data set. And yeah, that's pretty much it. Thank you so much for watching. See you next time.